Uh, Hello everybody, and today I will present the advancement in emission estimation module. That is a part of the platform that Sophie presented this some time before. Okay, as you know, emission generation and estimation is quite important and essential for the sector, and sometimes, in some cases, they have significant footprint. Knowing that the mining and quarrying are critical for Europe's construction, manufacturing, and infrastructure value chain, and these activities could generate substantial environmental pressures, particularly air emissions, but not only. Some of the impact and the assessment was presented by Gauti while presenting the module on life cycle assessment. But here we will speak about air emissions and direct air emissions that occurs directly on the site. A major impact on air quality and health is another very important issue, and that is why the assessment of air emission is quite important. One of the main pollutant is diffuse dust, and it's emitted across multiple operations within the sites, notably drilling and blasting, internal transport, crushing, screening, stockpiles, and handling. And it could lead to degraded local air quality and visibility, issues with health, and impacts on nearby community. So, dust concentration inquiries also can exceed exposure limit by orders of magnitude. However, it is not point of this module. Dust concentration and health impact will be explained by Eduardo in the next module. But it's really quite important to know that concentrations also is connected with emissions. So we know yet that diffuse dust is quite challenging for quarries, and we see in this graph that there are several emissions in European Union are attributed to extractive industries and especially to quarrying and mining, where PM 2.5 are essential emissions so far. And of course, there are some other operations that could produce emissions within the sites other than diffuse dust. They are explosive-related emissions. Normally, it's NOx emissions and CO2, and of course, emissions that also we spoke about this morning. Mezzo presentation about the fuel-related emissions, notably CO2, NOx, and also dust, but of course the others as well. It's also important because emission reduction is aligned with European Green Deal and Zero Pollution Action Plan, and they create opportunity for co-benefits. Because reducing emissions can simultaneously improve worker health, safety and health, and also reduce fuel consumption and explosive consumption, of course, and operational cost, and enhance environmental compliance and social acceptance. While it is important during Rotate project, we have developed a guide in order to reduce emissions. So it's emission reduction strategy guide. We really hope it will be helpful in order to identify the main operations that generate emissions, and so far then help manage it. And as you know, the first step, you see that there are several steps that we propose. The first step is identify dominant emission sources. The second step, setting a baseline and define targets. Step 3, at selecting abatement techniques per source and per air pollutant or greenhouse gas. Step 4, developing a roadmap and implementation plan. Step 5, implementation of technical and operational improvement. Step 6, monitoring and evaluation. And step 7, reporting and communication. Knowing that this guide is even more important for large quarries. Why? Because they are obliged to report their emissions to be in the register in European level so far. And as you noticed, the first step is identifying dominant emission sources. That this is all. It will be helpful for this to use emission estimation model of the platform. When you will see my several other slides, you will see the first presentation of the module that is still in development and will be developed by the end of the project, of course. And I will try to explain you why and how it is useful. First of all, here we estimate diffuse dust emissions, but also stack dust emission for the sources if they are in the quarry, but also fuel-related emissions and explosive-related emissions. Here you will see that there is a point on information, synthesis and report, and you also see the windows on emissions related to transport, fuel use, explosive use, and also then drilling and blasting operation, stack dust emission, diffuse dust emission from processing, internal transport, wind erosion, and material handling. So I would like you to present one by one this kind of the things that is within the platform. First of all, to better understand what it is about, you will have windows with information. What is this information? This information, it's the windows that explain what about each part of estimation. For example, first it's fuel and explosive related emissions, and it also explains formula. We put formulas, we put some additional hypotheses so far that you could be aware of it. Then there are explanation of what is all the operations that are including, like drilling and blasting, material processing, etc. And of course, the formulas and literature used in order to be implemented in the platform. Here, I would like to just give you two examples. First is drilling and blasting, and then material handling. So for drilling and blasting, first you have to report some data. I know that for some of you it could be challenging, but I think we tried to do as less information as inputs and to simplify it as possible. So then you could just give this information and you could receive the results, and these results will be visualized. That will help you to see what it is and how large emissions are. So then simulations are presented in the up of the page, and report, what is a report? It's presented in the second part of the page. And within this platform, within this module, you also could compare different years, as in the case of life cycle assessment model as well. So you could calculate, you could put the input data, here is material handling, and then see the emissions here, the year 2021 and 2025, and then analyze this information. So you see that this emission reduction could be simply because there are less amount of aggregates produced this year. But then you also see that, for example, the moisture content in the second year is much higher, so it also reduces the emissions. And also annual wind speed, that is quite different. More the wind speed, average wind speed you have, more there is emission dispersion. So less emissions are. And so far, you could have also in the results this comparative table and see, and then imagine what are, while using this platform, identify which are the most important emission operation, and then you could choose the measures in order to abate the emissions. And these measures are indicatively you could find in the handbook that is roaded handbook devoted to air and noise, and also in our emission strategy guide that you could use and so far manage the emissions. So here then you could have the synthesis of the information. What is the synthesis? It's the synthesis per pollutant. You could choose yet the year, you could choose relevant pollutants and or greenhouse gases. Up to now in the module we use CO2, but then maybe it would be possible to include more pollutants so far and greenhouse gases. Then you see the numbers, the emissions in absolute numbers, and also main contribution in order to help you to identify it and to organize, of course, then the mitigation measures. And also the predominant operations, so the operations that give you at least 80% of all emissions. And you also could see the main graphs. And you see that we have the window on information, on synthesis, but also on the report. Up to now, there is no in my presentation, but as of my knowledge this morning, it is well advanced, and it will be ready also the report that will be generated on this data by the end of the project. So what are impacts and benefits? So first of all, it's environmental performance of the quarries, identifying dominant emission sources, and also establish sound emission reduction strategy on this. And of course, reduction of emissions covered, and improving local air quality and reduced ecosystem impact, and contribute to climate mitigation. It will also help in the issues of health and safety inquiries, and that is more important, not more important, but very important, is operational efficiency with reduced fuel, explosive consumption and energy use, and more efficient process control and site management. And of course, it will improve economic performance, decrease operational cost, avoided fines and non-compliance cost, notably for large quarries, of course, and potential return on investment from abatement technologies, and also regulatory compliance, alignment with EU environmental policies, easier reporting and permitting, anticipation of future stricter regulation, and finally social acceptance and reputation due to reduced nuisance for local communities, improved stakeholder trust and social license to operate, stronger corporate environmental image. Thank you very much.